I am Hassan Farouk Afyouni, the managing partner of Steelwood Industries Dubai branch. My educational background is a chemistry major from the American University of Beirut, after which I went to the United States to the University of Central Florida. The major there, I studied and focused on industrial chemistry. I was part of research that was funded by the United States Army as a conductive polymer for millimeter wave screening material. Then attempted to do a dual PhD in physical and environmental chemistry in the University of South Florida. The research there was funded by NASA for groundwater remediation for chlorinated hydrocarbons. So it's always in the environmental. Even the Army fund was for environmentally conductive polymers. So the focus was always on environment. It's an environmental, human safety focus that I'm always looking at, and it's a concern for me. There was a fire in Mecca in 1995 and 1996 where some people died from the fire and the stampede that happened, I think, in Mina at that time. That was when I returned from the United States. Fire safety in general took my attention. So I started looking. I had a small lab in Lebanon, so I started doing some looking at what burns in the home and how to protect lives. So the commodities we have at home are, cottons, carpets, and tiles and textiles, and then one of them was wood. So wood, I have everything done for the other material. Wood kind of progressed with me. So I started inhibiting the flame on panels. So I came back, and then how do I get an investor to be interested? Since I'm in the Middle East, so the investor will want to invest in the Middle East. So I started that time to look at where are the resources? How can I generate resources? We know that the Middle East is about 95% deserts. So I had to look into the landfills. How can I start recycling the post-consumer wood, which we call today, and to take it from a burden to an appreciation. And that's the story. So that material was used to create the panels, which today we have introduced it as a new wood type in the world termed SDB. Steelwood was officially founded on the land of the UAE in 2012, but it was before that, since 1998 and 1997, after the Mecca fire. That's where the actual R&D happened. It was self-funded, and again, you're talking from a country out of the civil war, no infrastructure for research, no even people used to mock me what I'm doing. I'm wasting my money, I'm wasting my funds, I'm wasting my time. So you took that and it evolved. I had to, at that time, design my own presses, design my own shredders, design my own dryers, design my own formation from what was available in a country post-war. So this alone, the machines there are really the archaeology or the ancient art pieces of SDB as a type. This site you visited is a mill. Generally, mills are wood specific, species specific. So let's say I'm using the business as usual model. That I would require to trim trees, but I will have to trim one species type and calibrate the line accordingly. In Steelwood's model, we have the post-consumer random mix species of wood. So you have a mix of wood on a basis first in, first out, and we don't know the origin of the wood, the type of the wood, the age of the wood, nothing. So it's on first in, first out basis. It comes to our site, and from this technology, we generate a homogeneous SDB type. This factory you visited is really an experimental big prototype of the scalability of it. This can be scaled in every municipality on the globe, in every wasteland on the globe, depending on jurisdictions there and whatnot. In UAE case and in Dubai case, any material before it enters into a landfill is termed as raw material. So the contractors themselves have the option either to deliver it to a wasteland, then it's a landfill and it goes negative on their file, they're not environmental, or do we open an option to them, company to company, they deliver the waste that they produce from casting concrete or building material, they deliver it to Steelwood. Our EPD is cradle to gate. Okay, so the material comes to our site, we open a file for the contractor. It's a raw material now, so as long as we environmentally cater it, we're clear. So the material comes into our open yard in the back. We have certain requirements of acceptance of the material. Okay, we accept the material or we reject it. Okay, and then depends if it's MDF. Some people in the beginning were throwing in some nylon there and they thought we were a wasteland. We're not a wasteland, we recycle wood. So we had some criteria they're following. Automatically the material will go in a big shredder that will size it down to about 2 to 5 inch. Okay, then it goes to a cleaning system. It will have some construction waste residuals, some concrete residues, some nails, some metals in there, some non-metals. It flows through our system and it's further cleaned, where the nails are sent for recycling. The materials you get out, you send them for other entities, and then it goes into further hammer mills and flakers to size it, after which it passes into a big silo. During the crushing, you will get micro dust. This dust, if you see in the green cyclones around, this dust collects all this dust into energy, clean energy. It goes either to fire up our furnace or our boiler. So we have A, used UAE weather conditions, B, technology, C, automation, in a way that we were able to generate heat from the dust that is coming out as a waste from crushing the wood. Now the wood, the remaining wood now is in automatic silos. This wood automatically will leave the silo and go into a dryer. The dryer is powered again by the green dust that we have. The dryer produces the water content in the wood to the ratios we want, depending on the 40 SKUs that we have, and then it's segregated to surface and core, from which it goes back into a glue kitchen. And the glue kitchen in this industry is really where you dose the glue to the wood, the ratio of glue to wood. After the glue kitchen, you'll end up with sticky, treated wood chips. They will pass into a forming machine. The forming machine will also modified. It has this technology in it as well that will start forming the mat. It's called the sandwich. Now you will end up, after the forming machine, you will end up with like a dough, where you can cut it by hand, but it's firm. It will pass all the way to the press, where you will hot press it, powered by another boiler system, which is using our dust that we can use in production, but we are diverting for energy. Okay, so you will have the dough or the sandwich pressed into SDB. Again, each SKU has different requirements: temperatures, timing, cooking time, pressures, and whatnot. And then it will leave for cooling. Okay, they will queue in cooling. When they're cooled and ready, it's just a matter of the production rate. It goes into trimming to size as per international standards. It's cured for X amount of time. Then it will go to the sanding of both sides, and you have the boards that you see around here. Along the way, the QA people and the machines are always sampling for checking, and if there's any reject during the production, even what we trim, they end up either back to the line or back to recycling. In the definition, we use urea formaldehyde. Urea formaldehyde, there are other resins, but urea formaldehyde is one of the glues that have a lot of emissions, and they're not favored by many green codes. We make our own on-site urea formaldehyde. The general belief was the higher the emission, the stronger the glue. To make urea formaldehyde, you need urea and formaldehyde. And the free form, when they polymerize into urea formaldehyde. The marketing claims was that the more you have free formaldehyde, because that you only smell the free formaldehyde. When it's urea formaldehyde, you don't smell it. So the claims, the more you smell, the higher the emission, the stronger. We proved it false. Because really, the more you have no smell, you ensure that the resin is taken to a stronger urea formaldehyde form. The certification that we have proves, which from local labs and international labs, that SDB is a type, and it proves its mechanical properties. Why is it a type? Because it behaves differently than particle board, it behaves differently than MDF, it behaves differently than OSB, so it has different mechanical properties. The strength, for example, we can make elasticity. We can call its elasticity, when you compare it to other types, it's brittle. we can replace solid wood. We've done it, and we've done solid wood replacement, we've done MDF replacement, we've done particle board replacement, we've done plywood replacement, we've done OSB replacement. I believe the MENA region and the world should really look into recycling in general. We should minimize our natural resource consumption. Where we look at with the population around the earth, we have a huge reserve of natural resources in our landfills. There are many items that can be reused again and again if you have the technology for that as SDB to ensure that the virgin material can sustain humanity and life for the future. The MENA region and the world can generate also economies from this with the right technology. I'm talking about MENA region in general. Many countries in the MENA region don't have segregation to start with, and that's another challenge, that they need to segregate from source to A, minimize the cost, B, having the material ready, which allows recycling entities to entertain the landfills. Most governments have set plans for no landfills either by 2030, 2040, and unless scientists and engineers and investors, which is called really rewiring the economy again with bankers and economies and businesses together. Entering into reutilizing this resource, we cannot reach zero landfill. Will remain always a theory, and trust me, it can. Now it's needed more than ever, especially post-COVID, because the resources are there, and it can, what we call post-COVID economic recover countries that are in need today.